Okay, we move to the shell and tube heat exchanger for the construction detail design. Advantages of shell and tube heat exchanger are we can have the configuration give a large surface area in a small volume, and it has a good mechanical layout, which is it has a good shape for pressure operation, because for the heat exchanger it involved with the delta T, right? So basically, it also has significant on the pressure as well. Okay, uses well-established fabrication technique because it has, we can refer to the standard code or TEMA, and the standard code and design is well established. It can be constructed from a wide range of the materials, such as maybe for the tube part, we use the copper, and for the shell, we use stainless steel. Basically, we can play around with the wide range of the material, depend on the application of the shell and tube. And it easily to be clean because we can depend on the application. If example, if we choose the U tube heat exchanger, we can remove the U tube part, and then we can do the cleaning and maintenance on that. And it also has the established design procedure. So these are the type of the shell and tube. We have fixed tube heat exchanger, fluid heating heat exchanger. So you can see here, okay, we have the shell and tube. How can we identify whether which part are shell or tube? Okay, you can see here, this is how the fluid will be inserted into this. And we have a baffle here, so it will move. Okay, it will move across the baffle. So this is for the shell part, and then for the tube. Okay, I change the color. Okay, the tube here. So we have this side tube can be through this line. Oh, this is we have a fixed tube. That means the tube cannot be removed from this shell and tube. Okay, floating head. Okay, you can see we have a floating head. So this is the U, and we have the shell and tube part. So here we have the detail such as nozzle, we have the baffle, okay, we have, and also we have this we have a drain connection here. So you can see we have the shell cover, shell sheet. So all the detail you may refer to this table. And if we have a removable U-tube, so we can remove the U-tube after we open this side. So basically it's easy to be removed. So number one, you can see we have shell and shell cover here. This is number two. We have the shell flank. You may refer to this. This is flank. And we have shell nozzle, number five here, floating tube sheet, and so on. So you may refer to each number that indicate the detailed information on the component in the shell and tube. Okay, the established design of shell and tube is based on the TEMA or Tubular Exchanger Manufacturer Association. This is the set of standards that were developed by leading shell and tube manufacturer. So it already established the code and standard that we can decide which type we're gonna apply, and then use the design or guideline given by TEMA. Okay, this standard define the style of heat exchanger and the machining and also the assembly tolerance. Okay, the TEMA standards cover three classes of heat exchangers. So we have the class R, which is generally several duties of the petroleum and related industry. Class C for the moderate duties in commercial and general process application, and Class B used in the chemical process industry. For each class, you may refer here, we have the front end stationary head types, and we have the shell type, and also rear end head type. So basically, you may refer which design you may apply, and then after that, you may proceed to the detailed design and guideline given by TEMA. Okay, maybe I can go through in detail about the for each classification. Okay, we have example, if we have a design of a straight tube and fixed tube sheet, so we can use add the BEM, so combine BEM, and we can add the AEM, NEM, and etc. Okay, this is the most simplest design and most economical in most cases. Okay, the tube sheet is welded to the shell and head bolts to the tube sheet. The advantages are first, a less costly than removable bundle design, and it's capable of multiple pass designs. But the limitation are shell side can only be cleaned by chemical solution because it has a fixed tube sheet, no ability to absorb thermal expansion between the outer shell and tube bundle. Okay, for the removal bundle and externally sealed and floating tube sheet, okay, example, we can apply AEW. So A, E, and also W design here. So you can see the design for the shell part here. Okay, so it allows for the tube and bundle to be removed for inspection and cleaning. So because of the design of E, if you had a head here and we have the fixed tube inside here, so basically based on W here is external seal floating tube sheet. So basically we can do the inspection and cleaning. Okay, these are the list of the advantages. It has a floating tube sheet, allows for thermal expansion. Okay, shell side can be inspected and mechanical clean. Tube bundle can be replaced or repaired without breaking the piping on the shell side, and the maximum surface area for specific shell diameter for a removal bundle. And the limitation are tube side passes are limited to 1 or 2. So we cannot have more than 2 passes in the tube side. And the packing material limits operational pressure and temperature. And the third design is the removal bundle outside packet head. So this is example combination we can apply, allow for the easy removal, inspection, and cleaning of the shell side circle and shell interior without removing the floating head cover. Okay, the floating tube sheet allow for differential thermal expansion between the shell and tube. Okay, one of the advantage using this design. The second is the tube bundle can be repaired or replaced without disturbing shell piping. The tubes can be serviced without disturbing the tube side piping on a EEP design. Okay, less costly than TEMA, BES, and BET design. Okay, it provides a large bundle area entrance, reducing the need for entrance dome for a proper fluid distribution. Okay, but the limitation of flammable or toxic liquid in tube side circuit and good for high falling fluids in the tube side circuit. Okay, the other design are removal bundle internal split ring floating head, removal bundle pull through floating head, and removal bundle U-tube. Okay, the list of the remark and types are given here. Okay, example for the removal bundle based on the combination of AES, BES, and etc. This is the best application when frequent tube bundle removal is necessary. Usually, if related to the higher maintenance or troubleshooting and cleaning the tube. Okay, these advantages for the design are a floating head. A design allow for thermal expansion, maximum surface area for specific shell diameter than pull-through design like AET and BET, available to multiple passes on tube side. Compared to previous design, we can design it up to 2 passes only. But the limitation is shell cover, split ring, and floating head cover must be removed to remove the tube bundle. So we cannot easily remove the tube bundle only, but we should remove the shell cover, split ring. So the design is a bit complicated, and it tend to have we can have a higher maintenance cost. Okay, for the removal bundle or pull through floating head, Okay, this is the best application when frequent bundle removal is necessary as the floating head is bolted directly to the floating tube sheet. Okay, it has the same advantages with the removal bundle internal split ring floating head, except that it's suitable or more suitable for the volatile or toxic fluid. Okay, these limitations are chemical processing application for toxic fluid, and general industrial application require frequent cleaning, and the limitation on the hydrocarbon fluid condenser. Okay, for the removal bundle U-tube, okay, the maximum thermal expansion application, each tube has the ability to expand and contract independently. Okay, this design is suitable for high thermal shock application, which is U-tube bundles are very economical. Okay, the advantages are U-tube design not only allow for differential thermal expansion between shell and tube bundle, but also each tube individually, because it can be removed and the design is U-tube. Okay, shell side can be inspected and cleaning because we can remove the tube side. Okay, least costly design for removal bundle. The multiple tube passes side are available, and it capable of handling high thermal shock application, and bundle can be removed from one end for cleaning and replace. So instead of remove the bundle one by one, so basically we can remove U-tube as one bundle.